Hello, welcome to Mont Park Model Railway. In this video, I will be adding signals to the Litchfield double crossover that require signals in both the normal and contraflow directions. I possibly should start with a quick disclaimer. It is not intending to be fully prototypical, rather working with what I have to result in an operational capability on Mont Park Model Railway. These signals are to protect the junction. They will also need to show a fail-safe status that display a red signal by default and only green when the junction is safe to pass. The most common form of signalling is block signalling that indicates to the train driver the track section or block ahead is unoccupied and safe for the train to proceed. There's also junction signals that provide protection for track junctions. This is the form to be implemented for the crossing signalling. Regarding the signal post I'll be using, the top signal is indicating for the main line or normal route, and the lower signal is the diverging, switched or reverse route. My plan is to connect the signals in a manner that any time a point is against the train, the signals display a red and only display green when safe passage is possible. This means that when either of the mainline points are switched, they will display red for the mainline signals. The green for a successful crossover is only indicated when both sides are switched for crossing over. I spent some time in Excel working through the logic of the point motor switches and the signal display combinations. What I found was that greens were an AND of two switches and reds were an OR of two switches. Also found various combinations were paralleled or concurrent. Example, the upright straight green. To help visualize how the signals will operate with respect to the point switching, I made this small animation in an Excel spreadsheet. What it helped me understand is which signal aspects change together when the various red and green conditions occurred, and the likely circuitry that would be required to achieve the expected signal displays. I then moved into drawing the circuit diagram in Visio for a simple version of 2-point motor switches and the straight or mainline green-red signals. To display a green signal requires the switch ULP and CDLP to both be set to the straight direction, whereas the red signal can be either switch ULP or CDLP can be set to the turn direction. And the same for the alternate switch combination that still results in setting red, regardless of which combination is switched. The basic components of the circuit are point motor switches, diodes, and micro relays. It took several attempts to draw the diagram to achieve the logic for all switch combinations. It took a while to find the most efficient combinations for point switch motors, diodes, and relays. Was attempting to avoid using relays if possible, but ended up requiring 5 relays. It ended up requiring a complementary relay for each point motor switch and a 5th relay for the full double crossover combination. To build the circuit for the crossover will require 4 signals with 2 heads, each with 2 aspects, 4 point motor switches, 8 diodes, 5 12-volt single-pole double-throw relays, and some wiring. The build of the circuit was some parts from my uncle's old layout, supplemented with bits and pieces from my useful box. It did require recovering terminal strip blocks and micro relays from some old circuit boards. In Visio, I drew up the Vero board layout. This allowed me to identify all the links and wiring that would be required. Building the control board circuit. By happenstance, the drawing from Visio printed out 1:1 scale, which made the construction slightly easier. Started the assembly by mounting the relays, then the connector blocks, and fusing the two Vero boards together. The board assembly completed took most of a day. At this point there are a few errors, however. It required connectors to support inputs from 4-point motor switches and then outputs to 4 dual-head 2-aspect signal posts, resulting in over 30 connections. From my late uncle's collection, I was able to find 4 of the 2-head 2-aspect signals. These are brass with LED lights. The signals are to be located 30 millimeters from the track center and 60 millimeters from the point tie bar. Also needed to locate the signals before the baseboard join to ensure they were on the same board as the points and the control wiring. Started the installation of the signal pace, being careful with the very fine wires. It was a challenge drilling the hole for the wires for the signals that were very close to the baseboard joints. Needed to ensure the trains could pass the signals. Started by using a few Hornby coaches to check the signal clearances. Ended up using a steel rule width to verify a uniform clearance from track to signal. The signals have now been installed at either end of the crossover and ready for wiring. To connect the very fine signal post wires, I used a piece of Vero board to connect with larger wires and secure underneath the layout. Made up wiring looms for the signal post and the point motor switches so they can easily be mounted and, if necessary, aid fault finding. Mounted the circuit board underneath the layout ready for wiring. I attempted to repair some of the old Pico PL13 point motor switches. Started with over 30 of them, only 13 actually moved freely, however only one of the 13 had any electrical continuity when switching the mechanism. Pulled several apart, cleaned the leaf connection and soldered the wiring loom directly. The connection between the circuit board and the terminal was not making contact, and also the terminal would not take solder. It was like had a thin, greasy film. Possibly really should replace them with new ones. Attempting to retrofit the Pico PL13 point motor switches to the existing motors proved to be problematic. Attaching the switch to the would stop the motor from moving freely. This appears to be mainly due to the switch requiring the motor to be perfectly straight and aligned. This may have been possible on a new build when installing the motors brand new, but not so great for one that's 7 years old. Decided to use micro switches instead, which proved to be more straightforward and relatively easy to install. Took a little fettling to fashion the mounting, but was more flexible to adapt to the locations. The micro switches were actually easier to install than the afterthought retrofit of the Pico switches. The circuit all wired, tested and ready for operation. This is a run through of the point switch combinations from straight to full crossover and then back again. And now let's run some trains. Well, that's all for this video. Also Junction Signalling, and see you in the next one. Bye.